Namaste, Hamisha Khush Raho Betiya. My name is Manisha Singh. Today I am teaching you phytochemical and their usefulness, carotenoids. First of all, what is carotenoids? Carotenoids are the plant pigments responsible for the bright red, yellow, and orange hues in many fruits and vegetables. These pigments play an important role in plant health. People who eat foods containing carotenoids get protective health benefits as well. Carotenoids are a result of phytonutrients and are found in the cells of a wide variety of plants, algae, and bacteria. They help the plants absorb the light energy for use in photosynthesis, and they also have an important antioxidant functions of deactivating free radicals, single oxygen atoms that can damage cells by reacting with other molecules. Carotenoids also act as an antioxidant in the human body, and they have a strong cancer fighting properties according to the Physicians Committee for Responsible Medicine. Some carotenoids are converted by the body to vitamin A, which is essential to vision and normal growth and development. Carotenoids also have anti-inflammatory and immune system benefits and are sometimes associated with cardiovascular disease prevention. Next is sources of carotenoids. Carotenoid containing foods are often red, yellow, or orange, but not always. Carrot, yams, sweet potatoes, papaya, watermelon, cantaloupe, mangoes, spinach, kale, tomatoes, bell peppers, and oranges are among the fruits and vegetables in which carotenoids can be found. Animals cannot manufacture carotenoids themselves. They have to get in their diets. Carotenoids need to be consumed with a fat in order for the body to absorb them. According to the Linus Pauling Institute at Oregon State University, carotenoids need to leave the food they came in and become a part of mixed micelles, which are combination of bile salts and lipids, and the presence of a fat makes this process possible. Then the carotenoid family. There are more than 600 types of carotenoids, and the most common ones in the Western diet and the most studied are alpha carotene, beta cryptoxanthine, lutein, zeaxanthin, and lycopene, according to the Linus Pauling Institute. There are two broad classifications of carotenoid, that is carotenes and xanthophylls. The difference between the two groups is chemical. Xanthophylls contains the oxygen, while carotenes are hydrocarbons and do not contain any oxygen. Also, the two absorb the different wavelength of light during a plant's photosynthesis process. So xanthophylls are more yellow while carotenes are orange. Nutritionally, there is another potentially more useful grouping of carotenoids, that is provitamin A and non-provitamin A. Provitamin A carotenoids can be turned into the vitamin A in the intestine or liver. Vitamin A is an important component to human health, and it helps maintain eye health, healthy mucous membranes, and immunity. Alpha carotene, beta carotene, and beta cryptoxanthin are provitamin A carotenoids. Lutein, zeaxanthin, and lycopene are not. Then xanthophylls. Xanthophylls have lutein and zeaxanthin. Lutein and zeaxanthin are associated primarily with the eye health. Studies often do not separate lutein and zeaxanthin because they are the only carotenoids found in the retina. Lutein and zeaxanthin are accumulated in the human retina at the macula lutea, which is responsible for the central vision and protects the retina from the blue light, which may cause ionization and damage the retina. Scientists seem to know more about the lutein, and supplements typically contain much more lutein than zeaxanthin. Lutein and zeaxanthin are likely effective in age-related macular degeneration, AMD, a leading cause of blindness. A 6-year study from the National Eye Institute concluded that lutein reduces the risk of AMD, and it has been shown to reduce the incidence of cataract and light sensitivity if consumed in adequate quantities on a daily basis. Then beta cryptoxanthin. Beta cryptoxanthin is a xanthophyll carotenoid that is also a provitamin A, and it can be a source of vitamin A, but it produces half as much as beta carotene. Papaya, mango, and oranges are a good source of beta cryptoxanthin. Beta cryptoxanthin is typically found in yellow foods such as corn and bell peppers, and is present in yellow colored dairy products such as egg yolks and butter. Some study shows that beta cryptoxanthin may be effective in preventing lung cancer. Beta cryptoxanthin may be helpful in reducing the risk of inflammatory polyarthritis, which helps rheumatoid arthritis. Scientists suspect this is a base because its antioxidant abilities can reduce chronic inflammation, and in a large-scale European study published in American Journal of Clinical Nutrition, that had 40% less beta cryptoxanthin than those who did not. Participants who have consumed the most beta cryptoxanthin were significantly less likely to develop an inflammatory polyarthritis. The researchers advise that the modest increase in beta-cryptoxanthin, such as glass of juice a day, could be helpful in preventing arthritis. Next is the carotenes. Carotenes, number one is beta carotene. Of the provitamin A carotenoid, beta carotene is the more powerful when it comes to turning into the vitamin A. Twice as much beta carotene because becomes vitamin A than does alpha carotene or beta cryptoxanthin. Beta carotene was the first and is a most widely studied of the carotenoids. It seems to be capable of both positive and negative effects, especially for the smokers taking it as a supplement. Next is the alpha carotene. Alpha carotene produces half the vitamin A than that of the beta carotene does. Alpha carotene is found in the similar foods to the beta carotene and is often studied in conjunction with that carotenoids. Though it is rarer and less well stood, and recently scientists have paying more attention to alpha carotene and have found some potential longevity benefits in addition to the vitamin A goodness alpha can provide. Next is the good sources of alpha carotene include the pumpkin, carrot, tomatoes, collards, tangerines, winter squash, and peas. Next is the lycopene. Lycopene is a bright red pigment responsible for the color of watermelons, tomatoes, guavas, and grapefruit. Other good sources include the papayas, carrots, asparagus, red cabbage, red bell peppers, and parsley. The lycopene in tomatoes is absorbed much more easily if the tomatoes are cooked according to the Linus Pauling Institute. Lycopene can act as a potent antioxidant. Hope you all are satisfied with this session. This session is powered by Digital Version 2.0 Jayoti Vidyapeeth, Women's University, Jaipur. If you have any query, please mention it in a comment box. I will resolve them whenever we have a live session. Thank you so much for watching this video.